Hi, Math Dog here. So this video goes over graphing a system of linear inequalities. That would be two or more linear inequalities and finding a common solution if one exists. I list this as a grade 8 in the Common Core, but this certainly is something that will be talked about in any Algebra 1 course, and also actually would be usually covered, at least covered, possibly covered first time or reviewed in a geometry course as well. Videos not to be shared or reproduced without the consent of the creator, myself, the Math Dog. So it is highly recommended that you watch part 1 and part 2 of graphing a linear inequality before watching this video, because otherwise if you have done some of this before, you might not have a good technique of doing this. And I go over how to graph a single linear inequality in part 1 and part 2 of graphing a linear inequality. And then all this system thing does is you do each inequality one at a time, and then you see where the common solution is between the different inequalities, and that's what we're going to cover in this video. So in previous videos I talked about the dashed and solid lines. I'm not going to review that here. You'll see it when we do some problems. So for a system of linear inequalities, treat each inequality separate of the others. So in other words, do one at a time. For each inequality, determine if the boundary line is solid or dashed. For each inequality, write the inequality as an equation like we've done with a single linear inequality. Replace the less than, greater than, less than or equal to, or greater than equal to sign with equals. For each inequality's equation, solve the equation for y. Should be put in the form y equals mx plus b. Draw the line by first plotting the y-intercept, then construct some points using the slope to guide you. The only exception of this is when you have a vertical line, which will be the form the form x equals. For each inequality's equation, find a test point not on the boundary line. Plug the coordinates into the original inequality. If the test point makes the inequality true, shade the half plane on the side of the test point. So if you have a line or a boundary, could be dashed or solid, say your test point's over here, say it's 0, 0, which is usually the easiest one to use. So if when you plug this point into your inequality it makes it true, you will shade on the side that 0, 0 is of this what we called half plane. If it made it false, you would shade on the other side of the half plane. Okay, then the solution to the thing we're adding here is the solution to the system of inequalities is any shaded area shared by all the inequalities. So let's do an example. So we treat each one at a time. So this is going to be dashed because it's less than. This is going to be solid. So now the boundary equation here is x equals 3. The boundary equation here is y equals negative 2/3 x plus 1. So we're going to do one at a time. X equals 3, that's dashed. Well, that's a vertical line there. Everywhere x is 3. So that will look like this. Okay. Now before I go to the other one, I'm going to figure out how to shade this. Well, take a test point. I can use 0, 0 here. Plug it into the inequality. X is 0, 0 less than 3 is true. So this inequality will be shaded over here. Okay, then the other inequality, we're going to first work with the test equation here. Well, first we got to plot this. So the slope is negative 2/3. The y-intercept is 1. So I'm going to plot the y-intercept right there. And the slope is negative 2/3. So I'm going to go over 3 and down 2. Over 3, down 2. Over 3, down 2. That is a solid line. Okay, so now take a test point. Again, I can use 0, 0. Okay, so go back to the original inequality here. So plug in 0 for y. I'm using 0, 0 again. Less than or equal to negative 2/3 times 0 plus 1. Well, that reduces to 0 less than or equal to 1. That's true. So we're going to shade down. Because the point is in the lower half plane. So we shade here. Okay, so the common solution is where these two, the purple and red, intersect, which is going to be this area in here and anything that extends beyond it. So that's our actual solution, and it would include the blue boundary line but would not include the dashed. Remember, this graph goes forever in those directions, but it is stopped here by the vertical line. So our final solution is that trapezoidal area. Well, actually, again, it goes forever. So on our graph it looks like a trapezoid, but actually it goes forever down and to the left. Okay, another example. So let's first determine, are we shaded or are we solid? Well, this is solid because greater than equal to, and this is dashed because less than. So here we have the boundary equation y equals 1/2 x plus 1. Here we have the boundary equation y equals 2x minus 2. So now we're going to do these one at a time. So first, y equals 1/2 x plus 1. The slope is 1/2. The y-intercept is 1. The y-intercept is right there. Slope is 1/2. Go over 2, up 1, over 2, up 1, over 2, up 1, over 2, up 1, etc. So that's a solid line. So I'm going to draw a solid line through that. And again, it doesn't go through the point 0, 0. 0, 0, so I can use that as my test point. So going to the original problem, I have 0 less than or equal to 1/2 times 0 plus 1. Well, 0 greater than or equal to 1 is false. So I shade up because the test point's in the lower half plane. Because it's false, I shade the upper half plane. Okay. Then the other inequality, well, I have the test equation here, so I'm sorry, my boundary equation, y equals 2x minus 2, so the y-intercept is negative 2 right here, and the slope of 2 is 2 over 1, so I go over 1, up 2, over 1, up 2, over 1, up 2, etc. That is a dashed line. Okay, and once again, 0, 0 is not on this line, so I can use it as a test point here as well. Into this inequality. So y is 0, x is 0, 0 less than negative 2 is false. So my test point is above this boundary, so I shade the other half plane, which means I'm shading below. And that's the blue line. So notice the common shaded area is this in here. So does this area right here that I'm outlining right now, it goes this way and this way as well. But notice, so this is a dash line, so that is not included as part of the solution. This is a solid line, so it is. So this purple kite-like shape that I have here is my final solution of this problem. All those points make both inequalities true. And just for sake of argument, let's demonstrate that on just one of these. So let's use that point, which is 7, 6. So we're going to show it makes each of these true. So we're using 7, 6 as our point of the common solution. So 6 is greater than or equal to, because y is 6, I'm doing this one first, is less greater than or equal to 1/2 times 7 plus 1. Okay, so we have 6 greater than or equal to, well, 7/2 is 3.5 plus 1. That's true because 4.5 is less than 6. And then let's take into the other inequality, again, y is 6. That's less than 2 times 7 minus 2, because 6 is less than 14 minus 2 is 12, so that's true. So this is an example of a point that satisfies both inequalities, so it is part of the solution set. Okay, so now we have a system, but now they're in the form of standard form, ax plus by equals c. In the graphing linear inequality video, part 2, I talked about how to solve this for y. So first of all, this is a dashed boundary. This is a solid boundary because it's greater than or equal to. I'm going to move this over. So now the test equation, or the boundary equation here, is x plus 2y equals -6. Here the boundary equation is 3x minus 2y equals -2. So let's start with x plus 2y equals -6. Okay, so we got to solve this for y. So I got to get the y by itself. So I need to first, I'm going to put a 1 there, but I need to subtract 1x or x from both sides. So I get 2y is -1x minus 6. Solving for y, undo the multiplication, divide by 2. So get y is -1/2 x minus 3. So now we plot that boundary, which is going to be dashed. So the y-intercept is -3. The slope is -1/2, so it's falling downward, over 2, down 1, over 2, down 1, over 2, down 1, over 2, down 1. It's a dashed line. Let's take a test point. We'll use 0, 0. It's not on the line here. Plug it into the original inequality. 0 for x, 0 for y. 0 greater than -6 is true. So we shade up in the upper half plane. Okay, does not include that boundary. Okay, then the other equation, boundary equation, is (3x minus 2y equals -2). So solving for y, I first subtract 3x from both sides. So get -2y is -3x minus 2. Solving for y, undo multiplication by -2 by dividing by -2. So y equals 3/2 x plus 1. So we have a y-intercept at 1 right there, and we have a slope of 3/2. So we go over 2, up 3. Over 2, up 3, over 2, up 3. That is a solid line. It's supposed to be solid. Extend that. Alright, so we plotted both lines now. Again, 0, 0, which is right there, is not on this line, so I'm going to use that as a test point. So now we're doing, again, the solid line. So the test point's below the line. The original inequality is 3x minus 2y greater than or equal to negative 2. Plugging in 0 for x and y, we get 0 greater than or equal to negative 2. That is true. So we shade to the right half plane, so that's going to be over in here. Let's do that. So the common shaded area here is this right here. Which goes this way and goes that way. That is, this part is included in the solution because it's solid. This is not. This is not common intersection here, so that's not part of the solution. So again, the solution is outlined here. That's dashed, that's the boundary, and then it goes forever out this way and up this way. Alright, so now let's do this one. Let's put ones here for coefficients to remind ourselves we're going to have to divide by positive or negative 1. So this is dashed. This is also dashed. The boundary equation is 6x minus 1y equals negative 3. The boundary equation here is 1x minus 1y equals 2. So let's take the first equation. Let's move this over again. So we have 6x minus 1y equals negative 3. Solving for y, I have to get rid of the 6x, so I subtract to undo that added 6x on there. I subtract 6x, that goes away, bring down to negative 1y is negative 6x minus 3. Divide by negative 1. So we get y is 6x plus 3. So we have a y-intercept of 3 and a slope of 6 over 1. 1, 2, 3, 4, 5, 6. Let's go back 1 and down 6. Back 1, 1, 2, 3, 4, 5, 6. That's dashed. I think we can maybe get one more in there. Back 1, 1, 2, 3, 4, 5, 6. So now we draw a dashed line through there. And we can use 0, 0 as a test point, which is right here, which is in the right half plane. Okay, so plugging that into this, we have 6 times 0 minus 1 times 0 less than negative 3. 0 less than negative 3 is false. So the test point's on the right half plane. We shade the left half plane there. Over here. It's not going to include the boundary. Alright, so now let's do the other one, which is 1x minus 1y. And that equals 2. Solving this for y, I have to subtract 1x from both sides. I get negative 1y is negative 1x plus 2. Divide by negative 1. And I get, that's negative 1 there, I get y equals negative divided by negative is positive, 1x, positive divided by negative is negative, I get 1x minus 2. So plotting that, the y-intercept is negative 2, the slope is 1. So over 1, up 1. or over 1, down 1, back 1, down 1, negative divided by negative is positive. So draw that is a dashed line also. It's a dashed line. Let's do a different color. Okay. Again, 0, 0, the test point right there is not on the line, so we can use that as our test point. Plug it into the original inequality right here. 1x, 1 times 0 minus 1 times 0 less than 2. 0 less than 2 is true. We have the red line. The test point makes this true, so we shade up the upper half plane. So the common solution is this right here. That's dash, so the boundaries are not actually included in the solution. Okay, so now I'm going to do one with 3 inequalities just to demonstrate. So this is let's move that. So this is dashed, solid, solid. This is x equals 6, the boundary. This is 5x plus 2y equals 16 for the boundary. And this is y minus x equals 1 for the boundary. So let's start with x equals 6. That's a vertical line everywhere. X is 6, it's dashed. So that's just going to be, these points are going to be on that line. Dash though, not solid. Okay, now test point. Well, obviously here 0, 0 is not on the line. So plugging 0 in for x, 0 less than 6 is true. So we shade over to the left half plane. Okay. Alright, so then the second inequality. We have 5x plus 2y equals 16. Solving for y, I first have to subtract 5x from both sides. So I get 2y is negative 5x plus 16. Now I'd have to divide everything by 2. So y equals negative 5 halves x plus 8. So the y-intercept is 8, which is right here. The slope is negative 5 halves, so I go over 2 and down 5. Over 2 and down 5. Over 2 and down 5. Okay, and that is a solid line. All right, let's take a test point on that line. Well, 0, 0 is not on that line, so I can use it as a test point. So we're plugging it into this inequality. 5 times 0 plus 2 times 0 greater than or equals 16. That's false. So the test point's over here, so I shade to the right half plane. Okay, so we're over here. So far our common solution is in here, this triangle, but we have a third inequality, which is y. We're going to start with y minus x equals 1, the boundary. So let's again put coefficients of 1 there. Solving for y, I'm going to add 1x to both sides. So I get y equals 1x plus 1, so the y-intercept is 1. The slope is 1, so over 1, up 1, 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 etc. And that is a solid line also. Let's extend that this way. Alright, so let's take a test point, and again it's 0, 0 is not on this line, so we can use it. Okay, so the inequality is y minus x less than or equal to 1. 1 times 0 minus 1 times 0 less than or equal to 1. So 0 less than or equal to 1 is true. So we're going to, here's the test point, here's the boundary, we're shading in the lower half plane. So we're going to shade downward. So we're doing this. So notice that the common area of all three is this triangular area right here, and this actually is a finite area here. It's this triangle right here. That's your solution. So that is included in the solution here because that's a solid line. That's included, but this is not included because that's a dashed line. So that's a problem where you have more than two inequalities. Alright, so once you stop the video and do this problem, you'll need to shoot a graph paper and you'll need a pencil and a ruler to do it properly. I'll stop and then we'll go over this. Okay, let's look at the solution here. So the first one, the first inequality, I have, this is dashed. Second one is also dashed. The boundary equation here is y equals 1/3 x plus 3. Boundary equation here is y equals negative 4/3 x minus 2. So let's do this one first. So the slope is 1/3, y-intercept is 3, so the y-intercept is 3, the slope is 1/3 over 3 in the x, up 1 in the y, over 3 in the x, up 1 in the y, and that is a dashed line. As you can see, we can use 0, 0 as a test point. It's not on the line. Plug it into the original inequality, 0. So we're using 0, 0 as our test point. 0 less than 1/3 times 0 plus 3. 0 less than 3 is true. Test point is in the lower half plane, so we shade down. shading down here. All right. Then the other equation, or sorry, inequality, we have this, but our equation is negative 4/3 x minus 2. My y-intercept is negative 2 right there, and my slope is negative 4/3. So I go over 3 in the x and down 4 in the y. Over 3 in the x, down 4 in the y. I could also go back 3 and up 4. Puts me right there. That is a dashed line also. Get that to go there like I wanted to. Alright. Once again, does not go through the test point 0, 0, so we can use 0, 0 into this inequality. So we have 0 less than negative 4/3 times 0 minus 2. Well, 0 less than negative 2, that reduces to this, is false. So this time we have the purple dash line, which is slope of negative 4/3 x. That is false. So we shade not up towards the test point, we shade on the other side of the test point, so the left half plane or the lower half plane. So let's do that. So the common shaded area here is going to be going this way, but it's this area. It's not actually, that's wrong, sorry. It's not the common area. The common area is outlined here. So all this does not include this, does not include this, but it's that shaded area there. Let's actually do that a little better. So it's going to be this whole, let's be this. And it goes to the left. Like that, and it goes down. So it's that black trapezoidal area, but it also goes down and to the left. Okay, stop the video and do this problem. Okay, let's take a look at this. So both these are solid. So let's write the boundary equations. This would be x minus 3y equals 3. This would be x minus 3y equals negative 3. So let's take a look at the first one here. So we have x minus 3y equals 3, solving for y. Let's put a 1 there. Coefficient 1 on that x. So we're going to subtract 1x from both sides. So we get negative 3y equals negative 1x plus 3. So dividing by negative 3, we get y equals negative divided by negative is positive 1/3 x minus 3 divided by negative 3 is negative 1. So my y-intercept is negative 1. My slope is 1/3. So I go over 3 up 1, over 3 up 1, over 3 up 1. Then I can draw a solid line through those points. Again, 0, 0 is not on the line, so once again we can use it as a test point. Here's what we're going to do. And the inequality is x minus 3y less than or equal to 3. So x is 0 minus 3y, but y is 0. Less than 3, less than or equal to 3. So 0 less than or equal to 3 is true. So we're going to shade up. All right, the other line is x minus is also x, well, it's x minus 3y equals negative 3. So again, I'll put a 1 there, get the negative 3y by itself, so I subtract 1x from both sides. So now, to undo the multiplication here, I divide by negative 3. So get y is negative divided by negative is positive. Negative divided by negative is positive, so y is 1/3 x plus 1. So my y-intercept here is 1. My slope is also 1/3 like the other line, so I go over 3 up 1, over 3 up 1, over 3 up 1. I could go back 3 down 1, back 3 down 1, and this is again a solid line, I believe. Yes, so let's draw that line. So notice these lines are parallel, they have the same slope of 1/3, they just have different y-intercepts, they'll never intersect. So now let's take the test point, and 0, 0, let's put that in red, is right there, so it's not on this line either, we can use it as a test point. Okay, so we have 0 minus 3 times 0 less than or equal to negative 3. Well, 0 less or equal to negative 3, that is false. So here is our black line. Okay, it's false, so we shade away from this line. So we're shading here. So the common intersection, this area between the two lines is not part of the common solution. It's going to be this red area right here. And it does include the boundary this time because that's solid, and then it's going to go out this way, it's going to go out this way. And this concludes the video.